Alrighty, so we've got 7 SI base units and we want to draw this out. So let's go for 8 columns, and so we've got a header on there. So just to measure this out, we've got about 18 centimeters here. We want to divide that by 8. Well, that's a little rough. But if we go to 16 divides by 8 pretty nicely. So we'll just put some header on there, and we'll get that lined up with that top row. And we'll go here, and we'll go 2, 4, 6, 8, 10, 12, 14, 16, 18. And we'll go over here and start at about the same point, and we'll go 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. All right. So we've got 18 to 18 there. Draw a line across. 16 to 16 there. Draw across. That's 14 to 14 there. Draw across. That's 12 to 12. Draw across. Go that to that. Looks about right. Oh, I'm a little off. It's okay. It'll be okay. Take your time. There's no hurry. The whole point of this exercise is that people want to have all the information right away. And sometimes it's just better if you take a little bit of time to do things nicely. All right. That's looking all right. Okay. So where do we want to go from here? So let's see. What are our units? So let's talk about time. And, we were going to use colors. That's no good. Okay, well, I guess time is now blue. Time. And we've got, let's actually use black here. Unit name. So we have time. We've got length. We've got mass. We've got current. Electrical current. Put that there. We've got stuff. And the unit name for that is moles. And then we've got temperature. Absolute. And that is in Kelvin. And then we've got luminosity, and that's in candela. And then there's a spare for something else. So mass, our unit is kilograms. Electric current, our unit is amps. For length, our unit is meters. And then for time, our unit name is seconds. Okay, so we got that, and that. Put these all in their nice little ranking files so that we know what we're doing. Hopefully, we don't actually know what we're doing. This is a test. It should hopefully never show up, or if it is, it's in something highly embarrassing because I've done very well. Probably not going to happen. Okay. So we're just going to go through here and divvy that up. So we've got our unit names, and then we've got our abbreviation. Or a symbol. And obviously I can't spell worth a dickens. There is a mental constant. That should really be a defining constant. Okay, so what do we have here? We've got our symbol for time is S, and this is the frequency cesium hyperfine, defining constant. Defining value. And so what do we got here? So this is defined by hyperfine splitting of ground state cesium 133. That's the only type of cesium that's naturally occurring, so that makes it easy. And that's equal to 9192.631. Two cycles in a second. So this is about 9 gigahertz. Okay. Next up, we've got length in meters. That's got the symbol little m. It's defining fundamental constant, which is c. Speed of light. And this is, there are 299, 792, 458 meters in 1 second in vacuum. Light travels. So this is how far light goes in a second. So this is fixed. Okay, it's all good. Some of us have occasionally screwed that up. Okay, so kilograms. Everybody knows this is kg. So this is defined in terms of H, which is Planck's constant. And so here we've got C is equal to that. And delta V CS hyperfine splitting is that. So H is equal to 6.626 0.715 times 10 to the negative 34 joule seconds, which is meters squared per second squared. And I should be using negatives, but I'm old school, so I don't. That's kilograms. Meters squared. And so needs, length, and time. Whereas this just needs time. Maybe I should set up like a needs column here. Okay, electric current. Amp. So the symbol for amps is A. And this is defined in terms of the E. Proton charge. Also happens to be the proton charge, but just the sign flipped. So, and that is charge per unit time. And we've got E is equal to 1.602 6634 times 10 to the negative 19. This is the charge of electron. One coulomb is equal to 1 amp second. So it needs time. Okay, stuff, moles. Stuff. Substance. Okay. Unit name, mole. So this is defined by Na, which is Avogadro's number of OGA. Avogadro's constant. So Na is equal to 0.22 times 10. Oh, need to get the rest of the digits in there. 6.022. 14.076 times 10 to the 23rd. Atoms, molecules, etc. per mole. So then this is just a number. It doesn't need anything. Okay, then we've got temperature. Kelvin symbol is a capital K. And we define this in terms of KB, which is Boltzmann's constant. Notice how a lot of these are named after a person and they've got a constant. Okay, so KB is equal to 1.380 649 times 10 to the 23 joules per Kelvin. So this is meters squared kilograms per second squared per Kelvin squared. So it needs HCN. HC and so it needs time, length, mass, thermotemp. Okay, and finally, candela. The weird one. Luminous intensity. It's the candela. It's got a symbol of CD. Okay, and it is defined by KD. So for rad at 540 times 10 to the 20 hertz. I'm gonna guess that's green, but I need to look up. It's 683. LM per watt, which is equal to candela steradian per watt, which is equal to candela steradian per kilogram meters squared seconds to the third. And this one's a mess. I need to read more up of it, so I need to know the wavelength. I think this is physiological. I response, probably to green. This is how bright something appears to be. Okay, so there we've got a draft run of our SI base units, and from this we can derive everything else. Let's see how this all looks in production.